In this question, a scientist is investigating the reversible dissolution reaction of cesium oxide, CS2O. Dissolution means dissolving. So in other words, we're dissolving cesium oxide in water. Our first step is to fill in the gaps to balance the equation. So cesium-2 oxide is made up of 2 cesium plus ions and 1 oxygen 2 minus ion. So to balance our equation, we need 2 cesium plus and 1 oxygen 2 minus ion. Our next step is to write an expression for the solubility product constant, KSB, for this reaction in terms of the concentrations of the ions. Now, the solubility product constant is basically the equilibrium constant for a salt that is being dissolved. So we're going to use the same equation for figuring out the solubility product constant as we would to figure out the equilibrium constant, because it's the same thing. It's just a specific example of the equilibrium constant when we're talking about a solid that is dissolving. So here's the equilibrium constant. In the equation for the equilibrium constant, in the top half of our fraction, we have the concentrations of the products to the power of the coefficients of those products from the chemical equation, divided by the concentrations of the reactants to the power of the coefficients of those reactants from the chemical equation. And this note is really important. Only gases and solutions are included in the equilibrium constant equation. So let's go ahead and write the equilibrium constant expression for this particular equation. So on the top of our fraction, we're going to have the products. So we've got cesium plus ions, aqueous. Since it's either gas or aqueous, that can be included in our equilibrium constant expression. It's also got a coefficient of 2, so it's going to be to the power of 2. So we're going to have cesium plus ions to the power of 2. Also in our products, we have O2 minus, also aqueous, so that is allowed to be included in our equilibrium constant expression because it's either aqueous or a gas. The coefficient is 1, so that's just going to be to the power of 1. So that's going to be multiplied by the concentration of O2 minus ions to the power of 1. Remember, to the power of 1 is the same as just the thing itself, so we don't need to include that here. Then that's going to be divided by our reactants. Our only reactant is CS2O, and it's a solid. Since it's a solid, it doesn't get included in our expression. So we're not going to have anything on the bottom of our fraction here. It's just going to be 1 on the bottom. Since the only reactant we have is a solid, it doesn't get included. So we can go ahead now and fill that out here. KSP, remember that's just the equilibrium constant for dissolving, which is called the solubility product constant. So we'll have CS plus squared and O2 minus. Awesome. Okay, next we're told if cesium oxide has a molar solubility S, what are the concentrations of CS plus and O2 minus in the solution? Molar solubility, that tells us the solubility of CS2O, the solid. So how much of that is going to dissolve? Remember, if CS2O dissolves, that gives us 2 CS plus ions and 1 O2 minus ion. So if the molar solubility of CS2O is capital S, for cesium plus, we're going to have twice as much as we did of our CS2O because it makes 2 ions. So our concentration of CS plus is going to be 2S. For O2 minus, it's just going to be 1S because we only form 1 O2 minus ion from CS2O. So that tells us the concentrations of our cesium and oxygen ions in our solution in terms of the molar solubility. Our final step is to find an expression for the solubility product constant KSP, in other words, the equilibrium constant for dissolving, for this reaction, in terms of the molar solubility of the salt S. So all that means is we're going to take our expressions here for the concentration of cesium and oxygen ions in terms of S and substitute those into our expression for KSP here. So our expression for KSP was the concentration of CS plus squared multiplied by the concentration of O2 minus. Now all we need to do is substitute in our expressions here for the concentration of CS plus and O2 minus in terms of S. So for CS plus, it's 2S, and that's squared. For O2 minus, it's just S. So let's go ahead and multiply those out. 2S squared gives us 4S squared multiplied by S. So that ends up with a KSP of 4S cubed. Let's fill that out down here and check that worked. We've got 4 times S cubed. Awesome. So the steps in this question are first balancing our equation, thinking about how many ions are going to be made from our compound. Then we're figuring out our solubility product constant, KSP. Remember, that's exactly the same as finding the equilibrium constant. Next, we're going to think about the concentrations of our ions in terms of the molar solubility of our overall compound. So if you make multiple ions, 2 or 3 ions of a certain type, you're going to have 2 or 3 times the molar solubility for the concentration of those ions at equilibrium. Finally, we're going to substitute in those expressions to our KSP equation in order to get an expression for KSP in terms of the molar solubility of the salt S.